Okay, good evening, students. So today we are here to revise how to write chemical formula. So that's the first thing we will do. How do I write chemical formula? Then after writing chemical formula, we will learn how to balance equations. As we learn how to balance equations, we will revise the reactions of acids. Okay. Now, why did I choose reactions of acids to be the examples for the equations today? Now, this is because typically in your O-level combined science paper, the equations that we ask you to write are never equations that are very difficult. They are rarely equations that are very foreign to you. Very often, we ask you to write equations involving reactions you have learned. And the most important reactions you have learned are the ones involving acids. So we shall revise the 3 reactions of acids today as we balance the equations. But first, let's start with chemical formula. Now, to write chemical formula correctly is the first step towards writing an equation. If the formula is wrong, the equation is wrong and automatically given 0 marks. So the formula must be correct. Okay? Now, to write chemical formula correctly, you need to have good understanding of bonding. So in the previous training sessions, we actually went through ionic bonding, covalent bonding. So if you are still unclear about ionic and covalent bonding, you should go revisit those previous videos found in our playlist. All right, but let's start with chemical formula first. Now, obviously, as I mentioned, chemical formula, you need to know a type of bonding. What if the type of bonding is ionic? Meaning it's an ionic compound. All right. Now, if it's an ionic compound, you need to consider the charges on the ions. Take, for example, if I were to tell you, you should write the formula of sodium oxide. So this is a compound, but how do I know it has ionic bonding? I know it has ionic bonding because it's a metal. Oxide comes from oxygen. Oxygen is a non-metal element. Okay. Now let's refresh a little bit. How would you know that something is a metal just based on its name? Well, if you know it's sodium, you will look for sodium in the periodic table. In the periodic table, the metal is on the left side. Metals are found on the left of the periodic table, whereas non-metals are found on the right side. Okay. Now, so this is how you tell whether something is a metal or non-metal. Clear? Now, first, once you know it's a metal and non-metal, the bonding is ionic. Once you know it's ionic, you absolutely must get the charges correct. How would you get the charges correct? You need to figure out, okay, sodium is group number 1. Group number 1 will lose 1 valence electron. So it will form 1 plus charge. Okay? Oxygen, group number 6. Group number 6 means 6 valence electrons. To form a fully filled outermost electron shell, it needs to gain 2. Now, if you look at how I've written it, gaining 2 electrons means 2 minus charge. So it's O2 minus. The charges are written on the top right-hand corner of the ions. But this is not the final formula yet. In order to write the final formula, the concept is that the positive and negative charges must balance out. Currently, as it is, sodium ions have a +1 charge. Oxide ions have a 2 minus charge. They do not balance. In order for them to balance, you got to ask yourself, okay, how many of each ion do I need? Oxide is double negative. That means 1 oxide ion has a double charge. That means sodium must be doubled in number. Therefore, I need 2 sodium ions in order to balance 1 oxide ion. So what the number at the bottom? Number at the bottom means the amount of the ion. So what you have in this case is 2Na plus and 1 O2 minus. And that makes full sense. Sodium has a +1 charge. It needs to have 2 sodiums to balance out 1 oxide ion's charge. Okay? Okay? So that was sodium oxide, a good example of how you need to write chemical formula carefully. Let's move on to another example. So what if I give you another ionic compound? Aluminium oxide. So again, you will need to go and search in the periodic table. Aluminium is a metal. Oxide comes from oxygen. Oxygen, non-metal. So again, this is ionic for sure, because there's metal and non-metal. Next, you need to work out, okay, aluminium, oxide. So oxide is easy, we worked it out just now, right? Oxide, 2 minus. But how about aluminium? Aluminium is group 3. So you realize that it's very, very crucial to get the group correct. Once you know it's group 3, you have to work out, okay, group 3 means what? 3 valence electrons. If it's 3 valence electrons, to achieve a fully filled outermost shell, it will lose 3 valence electrons. So when you lose 3 electrons, the charge is 3 plus. It's positively charged because you are losing 3 negative electrons away. You are getting rid of 3 negative electrons. So the overall charge left should be 3 plus because you are losing negative charges. All right. So once you have the charges written out, you realize again it's not balanced, right? The concept is that the positive and negative must balance out in charge. So how would you do that? Well, a little bit of quick math will tell you, okay, 3 and 2. Clearly, to balance out, they must go to a common multiple. So you have learned this in Sec 1, Chapter 1, right? The first thing you learn in Sec 1 is numbers. Specifically, you learned lowest common multiple. So the lowest common multiple, of course, between 3 and 2 is 6, right? So the question now is, okay, clearly 3 plus, 2 minus are not balanced. What if I have 2 Al3 plus and 3 O2 minus? This works, right? Because 2 Al3 plus total 6 plus. Negative charges, each is 2 minus. If I got 3 of it, total 6 minus. So finding the lowest common multiple would allow you to quickly work out, oh, I need 2 aluminium ions. I need 3 oxide ions. Therefore, the formula is Al2O3. Okay, that's the final formula of aluminium oxide. Okay. Now, so as a summary, okay, the idea is the positive and negative charges must balance out. So whenever you write an ionic compound, you must first write the charges out. Don't be impatient and rush into assuming that there must always be one of each ion. It doesn't work that way. In fact, in these examples that we have just seen, there is more than one of the ions, right? It is not a clear 1:1 ratio. Okay? Now, obviously, for something as complicated as aluminium oxide, a quick way is to do the cross multiplication method. The 3 at first was with the aluminum in the charge. The 3 can come down below the O. The 2 can go below the Al. Now, when you do this cross multiplication method, you will get Al2O3 very quickly. And this is a good method to use for more complicated compounds. Okay, but essentially what you are doing with this cross multiply method is you are still finding the common multiple, like what I've done by drawing it out. Okay, what you are doing is that you are ensuring that, okay, I have 2 aluminum ions and 3 oxide ions, and that's why the plus and minus will balance out. All right. Okay, let's do one more simple example. Magnesium chloride. Now, magnesium chloride is a very commonly tested formula. You should learn magnesium chloride quite well. Again, it's quite obvious. Magnesium is a metal, right? Magnesium is a metal. Whereas chloride comes from chlorine. Chlorine is a non-metal. Okay? So magnesium, group 2. You must look for magnesium in the periodic table. It's in group 2. So it has 2 valence electrons. It will lose 2 valence electrons and it will form a 2+ charge. All right. Chlorine, group 7. So chlorine is a halogen because it's found in group number 7. Okay, group 7, they are called halogens. They are all non-metals. So group 7 has 7 valence electrons. So chlorine has 7 electrons in the outermost electron shell. If it has 7 valence electrons, would it lose 7 electrons or will it gain 1 electron? Remember, the magic number is always it wants to achieve a fully filled outer shell, which is 8. How does it make 8 from 7? It is easier to gain 1 valence electron. So gain 1 electron, it forms a 1- charge. Usually we leave the 1 out, so we just write Cl-. So the chloride ion is Cl-. So again, it's quite clear-cut. The plus and the minus do not balance out. Magnesium has a double positive charge. Chloride has a single negative. So the formula, magnesium has a double charge, so we don't need more of it. But we need double the number of chloride to balance out magnesium. So the formula of magnesium chloride is MgCl2. Okay? Can? So in summary, these are just simple ionic compounds. In summary, you must write out the positive and negative charges out first before you end up with the final formula. And the charges can be deduced from the group number. So as you saw today, group 1, 1+ charge. So like Na+, K+. Sodium, potassium, they form plus. Group 2, 2+. So Mg2+, Ca2+. Group number 3, 3+. So Al3+. Okay. Then we move to the non-metals. The non-metals are like group 7, 1-. So Cf-, Cl-, Br-, I-. They all will follow this trend. Group 6 will gain 2 electrons, so it's 2-. Group 5 gains 3 electrons, 3-. Okay, so this is a quick summary of the relationship between the group number and the charge that you will form. Okay. Okay, so now let's move on to write more complicated formula involving ionic compounds. The more complicated formula involves polyatomic ions. For example, how would you write the formula of magnesium hydroxide? So magnesium is easy. You know it's just Mg. It's a metal, right? This metal, magnesium, is found in group 2. Group 2, based on the trends that we have done, group 2, the ion form is a 2+ charge. The trouble is with hydroxide. As the name suggests, it's not just oxygen inside. It is a polyatomic ion containing oxygen and hydrogen, OH. And the O and the H are covalently bonded together. However, this OH has an overall charge of 1 minus. How do I know that the overall charge of OH is 1 minus? This is where memory work comes in. For the polyatomic ions like hydroxide, you must remember the charges on the ions. So hydroxide is OH minus. Now, quite clearly, once you have written the charges out, you realize that the charges aren't balanced. To balance them quite clearly, magnesium has a double charge, but hydroxide only has a single negative charge. Therefore, okay, we will need to have twice the amount of hydroxide. So how do I represent twice the amount of hydroxide? Clearly, we have to put a 2 below the hydroxide. But remember, we are saying there's 2 hydroxide. You must place a bracket. You will have to place a bracket when there is more than one of the polyatomic ion. So hydroxide is polyatomic, O and H, right? Bonded together covalently. The whole ion, OH, has a -1 charge. So I need 2 times the number of hydroxide ions to balance out a single magnesium ion. So I must put a bracket around the OH because there's more than 1 hydroxide ion. Okay, so we only use the brackets when there is more than 1. When you need to put a number below it, then you put a bracket. And this applies only to polyatomic ions. You notice just now, I didn't put brackets because those are not polyatomic. Okay, so how do I know it's polyatomic? When there's more than 1 atom bonded together in the ion. So OH minus is polyatomic. Now, another common polyatomic ion, and we will continue to use magnesium for now, is magnesium, and another common one is nitrate. Magnesium nitrate. So magnesium again is Mg, the charge is 2+ because it's in group 2. Now nitrate is one that you have to memorize. Now you must be able to distinguish when the number is at the bottom and when the number is on top. When the number is at the bottom means there is 3 oxygen atoms in the ion. These 3 should not disappear in your formula. So in your final formula, you should still have NO3. This is a unit, a block that should not be separated. It should not be disappeared. All right. So when in our final formula, we must still see NO3. Yeah? It shouldn't become NO. No, the 3 must still be there. So the number at the bottom always tells you the number of the atom present. So in this case, it means there are 3 oxygen atoms present in the nitrate ion. And these 3 shouldn't disappear. So once you know that the 3, what's the meaning? You realize, oh, 3 is not the charge. 3 is the number of oxygen. The charge itself is just on top, right? The charge is always on top. The charge is 1 minus. The 1 is usually omitted, but from this we know the charge on nitrate is 1 minus. That means the nitrogen and oxygen are covalently bonded together. The whole molecule has a -1 charge. So nitrate only -1, you know, but magnesium again 2+. Magnesium has double positive charge. Therefore, we conclude magnesium is doubly positive. So to balance out my magnesium's double charge, I need 2 nitrate ions. And you can clearly see my 3 hasn't vanished. It's still there. All right, so magnesium nitrate, Mg, bracket, NO32. All right. Now, at this juncture, it is important for us to recognize. So if I were to count how many magnesium, how many nitrogen, how many oxygen, how do I count? So magnesium, only 1. The 2 only applies to everything in the brackets. Magnesium is not in the bracket. So magnesium, only 1. How many nitrogens are there? So remember, the nitrogen is inside the bracket. The 2 will apply to everything inside the bracket. You have to multiply into the bracket. So nitrogen, there's 2 nitrogens. How many oxygens are there? So many students are confused. They will say 3 plus 2 equals 5, 5 oxygen. That is incorrect. You multiply in. So it's 3 times 2, which is 6. Okay? So there are 6 oxygens. And this makes perfect sense because when you write Mg bracket NO32, what you're saying is this: 1 magnesium ion with 2 nitrate ions. When you have 2 nitrate ions, you have a total of 2 nitrogen and 6 oxygens. Okay? So this is basically how you write formula. Now, so which ions do you have to memorize? So I shall give you the list now. Hydroxide must be memorized, OH minus. Nitrate, NO3 minus. Carbonate, CO3 2 minus. Sulfate, SO4 2 minus. Okay, so the charges are important. Please learn. All right. So these are the negative ions. How about the positive ions? Ammonium, NH4 plus. So the charge is 1 plus. The 4 is at the bottom, which indicates there are 4 hydrogen atoms. Okay. So these are your polyatomic ions. Of course, these are not the only ones. There are more. But for a start, you must memorize these 5 polyatomic ions. You have to memorize their formula. How many oxygen they have, what's their charge. Now, other ions to memorize. So the other ions are not polyatomic. The other ions to memorize are zinc. Zinc is Zn2 plus. Silver, Ag plus. So this is crucial to know. So these must be memorized. Okay, so in short, this list must be memorized. Okay? Okay, so we have just finished ionic compounds involving polyatomic ions. Now, before we go on to covalent compounds, let's go through one last example, which is if there's a Roman numeral written. So for example, what if I ask for the formula of iron 2 nitrate? So some of the metals like iron and copper, you cannot just say iron nitrate. You have to have specified a number. Now this number 2 indicates the oxidation state of iron is +2 in this compound. So we have already learned oxidation states under reduction and oxidation. So what does it mean to say iron is +2? Another way to say this means iron has a 2 plus charge. Another way to say oxidation state of iron is +2 is to say that the ion present is Fe2 plus. Now, the moment you know there's Fe2 plus, things become very straightforward because nitrate you memorize is NO3 minus. Remember, NO3 with a 1 minus charge. So 2 plus on the iron, 1 minus on the nitrate. Therefore, to balance out, I need 2 nitrates to balance out the double positive on iron. Okay, so remember the 3 doesn't disappear. The 3 still must be there because that is the number of oxygen. It should not vanish. Okay, so the formula of iron 2 nitrate is Fe bracket NO32. So today we also go through the meaning of the Roman numeral next to the metal's name is the oxidation state of the metal. So in this case, iron is +2. That means the charge is 2+ on iron. Okay, so this is an example of how you write a formula involving a metal that has a number written beside it. Okay, so now let's move on to the formula of covalent substances. So as mentioned in our previous lesson, covalent bonding is when 2 non-metals share valence electrons. So the idea here is 2 non-metals. You know something is a covalent substance if they are only non-metals. There should not be a metal in its name. So take for example, carbon dioxide. Carbon is a non-metal. Oxide comes from oxygen. Now, for covalent substances, there's no charges to speak of because they are not ions. So the way to write the formula is to work on prefixes. The prefix is di. Di means 2. 2 oxygen. Therefore, the formula is CO2. Okay, let me write the C closer. So the formula is CO2. Similarly, if I told you it's sulfur trioxide, tri means 3, so SO3. Okay. Finally, carbon tetrachloride. C, chloride Cl, tetra means 4. CCl4. Okay, now so prefixes, di means 2, tri means 3, tetra means 4. Now this is not the only ones, it goes on. The next few you also should know. Phosphorus, pentafluoride. Phosphorus is P, fluoride comes from F, penta means 5. You have learned pentagon. Pentagon has 5 sides, so the prefix penta means 5. Sulfur, hexafluoride. So again, you can imagine sulfur, fluoride is F, hexa means 6. So di, tri, tetra, penta, hexa. So the prefixes basically tell you how to write the formula. Now, this is very helpful. Basically, covalent substance is super easy to write. You just need to know how to write the prefix. Okay? So even if I give you something really complicated like this, dinitrogen tetroxide. Then you'll be like, what? But slowly work it out. Di means 2. So dinitrogen means N2. Oxide comes from oxygen, right? Tetra is 4. So dinitrogen tetroxide is N2O4. Okay? So the prefixes will tell you how many of the atom you have in the covalent substance. So this is system of prefixes is used for covalent substances. Okay? However, there are some covalent substances that needs to be memorized. Okay, don't worry, there aren't too many of these. The first one is ammonia. Ammonia is NH3. All right. Now, this is easily confused by students with ammonium. So just now you had ammonium, which is a polyatomic ion, NH4 plus. But ammonia ending with IA is NH3. The next one to memorize is methane. Methane is CH4. So these two are the common covalent molecules which you should try to memorize because obviously their formula doesn't link with the name. Of course, one more you should memorize is water. I suppose you know water is H2O. All right. Now, at this juncture, we would have seen how to write chemical formula for both ionic and covalent substances. Okay, this would have covered all the formula that you would need for the O-level combined science chemistry exam. All right. Now, so just to revise, ionic compounds. Ionic compounds, you need to write the charges out, the positive and the negative charge. The concept is that the positive and negative charges must be balanced out in an ionic compound because ionic compounds should have no overall charge. Okay. Now, for covalent substances, this involves two nonmetals sharing their valence electrons. So in covalent substances, we do not have any charges. What we have though is a system of prefixes. The prefix tells us how many of each of these atoms you have. Okay, so such as di means 2, tri means 3, tetra means 4, and so on. Now, once you have mastered the formula, then can we progress to writing equations? So it is important to learn to write formula well, all right? Because if the formula is incorrect, like I said, the equation will be marked totally wrong, all right? So now, once you have learned how to write the formula, we start with equations. So now we are moving on to equations. Whenever you are writing an equation, it is important to know what is the reaction. Is this an acid plus metal reaction? Is this an acid plus carbonate reaction? You need to know what is the reaction, because if you know what the reaction is, then you know what are the reactants and what are the products. Right? You need to know what do you start with, what do you end with. Okay? Now, this is usually not told to you in the exam. In the exam, you are expected to write the equation just based on recognizing what the reaction is. For example, they may ask you, write the balanced chemical equation for the reaction of magnesium with nitric acid. This is usually the question, right? 2 marks. Write a balanced chemical equation for the reaction between magnesium and nitric acid. So you need to know what is the reaction, right? And what are the reactants and what products do you form? Okay, and this is where your knowledge of acid reactions comes in. Okay, so let's start with acid reactions. The first reaction, of course, is acid plus metal. Acid plus metal forms salt and hydrogen gas. Okay, so you form hydrogen gas from acid plus metal. So for example, if it's nitric acid plus magnesium metal. How do you know magnesium is a metal? You look in the periodic table. Magnesium is in group 2, is a metal. It forms a salt. What is the salt's name going to be? The salt's name will start with the metal. So it's magnesium. And the second part comes from the acid. Nitric acid becomes nitrate. All right. So it is important to know the reaction. Once you know the reaction, then, so it forms the salt, magnesium nitrate, and hydrogen gas. So you know the product. Now, once you have gotten this, the next step is to write chemical formula. Nitric acid is HNO3. Got to memorize. Magnesium is just Mg. Take note, no charge. no charge on metal. It only has a charge when it's in a compound. But magnesium is not a compound. Magnesium is an element. So on the element itself, if it's just magnesium on its own, no charge. The next step is ultra crucial. And many of you do not do this. Many of you do not do working. You just straight away write this. Is this formula correct? Can we really assume there's one magnesium and one nitrate? Is this how you write formula? Just assume there's one of each. Of course not. This is wrong. So what must you do when you write formula? When you write formula, don't rush. Work out. Magnesium nitrate, Mg2 plus. Nitrate, NO3 minus. Then you realize, oh, 2 plus minus. Clearly, the formula is not 1 nitrate, 1 magnesium. It's 2 nitrates, 1 magnesium. Okay, so I'm highlighting the commonly made mistake, which is many of you just assume it's one of each. It's not. You need to work out the charges and write out the charges. Make sure the positive and negative are balanced out and cancel each other out, okay? And with that, once you have this, it's 1 mark. Then where is the last 1 mark from? This equation is not balanced. Why is it not balanced? Because it doesn't have equal numbers of atoms on both sides. A balanced equation must have equal numbers of atoms on both sides. So we balance the equation by writing coefficients in front of the substance. The purpose is the number of atoms should be the same on the left-hand side and right-hand side. Okay, so let's see what's not the same. We will start by counting the metal. Always start by counting metal. 1 magnesium, 1 magnesium. Magnesium is okay. What's not okay? Nitrate, nitrate. So we can treat the NO3 as 1 unit, 1 block. On the left, you have 1 nitrate. On the right, you got 2 nitrates. Clearly not right. I must ensure the nitrate is the same on both sides. How do I ensure it's the same? I add coefficients in front of the substance. So I should add it in front of where? I need more nitrate where? I need it on the left. I put the 2 in front of nitric acid. And that would make the equation balanced. So once you do it slowly like this, you would have gotten 2 marks. So like I said, don't make the mistake of assuming there's 1 of each ion. Make sure for magnesium nitrate, the salt, you must write out the charges and ensure the positive and negative are cancelling each other out. Once the formula of magnesium nitrate is correct, then you proceed to balance the equation by adding coefficients in front of the substance, with the purpose of ensuring the number of atoms is the same on both sides of the equation. Okay? Okay, so we have just seen acid plus metal reactions. That is one of the 3 reactions of acids. Okay, the next reaction we will go through is acid plus carbonate. Acid plus carbonate forms salt, carbon dioxide, and water. Now, this is easy to remember because a carbonate will always produce carbon dioxide as a product at the end of its reaction. So carbonates are associated with producing carbon dioxide gas. All right. So another example, hydrochloric acid plus calcium carbonate. So how do I know it's a carbonate? How do I know calcium carbonate is a carbonate and not a metal anymore? I recognize the word carbonate. The moment I see the word carbonate, I know, okay, it's a carbonate. It's not a metal. Therefore, I need to know, okay, this is acid plus carbonate. It produces salt, carbon dioxide, and water. Now, what is the salt's name going to be? As I mentioned, the salt's name starts with the metal element in this question. The metal element is calcium. So the salt's name must start with calcium. The second part of the salt's name comes from the acid. The acid used is hydrochloric acid. Therefore, it forms the chloride. So it forms the salt, calcium chloride. Calcium is the metallic element. Chloride came from the hydrochloric acid. Okay. Now, this is again where you must be absolutely careful. Hydrochloric acid is HCl. But what is calcium carbonate? Again, when you see names like ionic compounds, you know that, okay, this is a metal and non-metal, right? Calcium carbonate. You need to know the charges. Ca is 2+ because calcium is group 2. Carbonate is 2- because you have memorized the polyatomic ions, including carbonate. So now that you know, oh, so it's 2+ and 2-. Therefore, the formula is really CaCO3. Okay, just one of each because the plus and the minus already cancel each other out. Then we do calcium chloride. Calcium is 2+. Now, what about chloride? Chloride is just Cl with a charge, right? Chlorine is from group 7. 7 valence electrons, it gains 1. Therefore, you realize the first problem. The formula, is it CaCl? Can it just be 1 calcium, 1 chloride? Just based on the charges, you know this is wrong. This is also a common mistake that all of you make, which is, again, you assume 1 and 1. It's not. Don't assume it's 1 and 1 until you write the charges out and compare. Immediately you realize, okay, I need twice the number of chloride ions. Because calcium has a double positive charge, I need twice, double the number of chloride to balance out calcium. And with that, you have written the formula correctly. And this will get you 1 mark already. Conversely, if you had rushed into doing it and written CaCl, you would have gotten 0 marks. So please make it a point to write the charges. The next step, of course, as we mentioned, is to balance the equation by adding coefficients in front of the substance. So you count the atoms first. Count to make sure whether they are same on left-hand side and right-hand side. Which atoms should you count first? Always count the metal first. Calcium is the metal element. I have 1 calcium on the left, 1 calcium on the right. Calcium is balanced. Then, after the metal is done, you count non-metals. Non-metals like group 7, chlorine. You can count nitrogen, group 5. Do not count oxygen and hydrogen. Oxygen and hydrogen you balance last. So in this case, don't count the O, don't count the H, count the Cl. Immediately you realize the problem, right? On the left-hand side, there's 1 Cl. On the right-hand side, there are 2. Therefore, you need to put a 2 in front of the HCl. Now, when you put a 2 in front, what does it actually mean? HCl is like this. This is 1 HCl. 2 HCl means what? You have twice the number of HCl. But the 2 HCl are not bonded. Now, many of you think, why must the number put in front? Why the number cannot put at the bottom? If the number is put at the bottom, that means it's bonded together. But what you are trying to say is you need twice the amount of HCl. So the 2 must go in front. So this is 2 HCl. If you had written HCl2, which is incorrect, what you're trying to say is that you have HCl and they're like bonded together somehow, which is incorrect. The 2 at the bottom means bonded together. Okay, so this is incorrect. Do not make this mistake. Do not make this mistake. Wrong. All right. So please understand where the 2 is. The 2 in balancing must go in front, because what you're saying is that you have twice the amount of HCl. Okay, so at this juncture, you realize that we have just gone through acid plus metal, which forms salt and hydrogen, acid plus carbonate, which forms salt, carbon dioxide, and water. All right, now at this juncture, you realize we have already dealt with a few acids, right? Nitric acid, hydrochloric acid. So it's time for us to summarize. Nitric acid's formula is HNO3. Hydrochloric acid, HCl. Finally, the last one, sulfuric acid, H2SO4. So immediately you realize, oh, there's something unique, right? They all contain hydrogen and something else. So nitric acid, obviously, forms the nitrate. Hydrochloric acid, the salt form is the chloride. Sulfuric acid, salt form, sulfate. Okay, so you need to know this very, very well. Okay. Okay, so we have gone through acid plus metal that forms salt and hydrogen gas. We must take note hydrogen gas is H2. All right, it's diatomic. Next, we have gone through acid plus carbonate that forms salt, carbon dioxide, and water. The last reaction is, of course, acid plus base. Okay, so this is a revision of acid reactions. So you have learned acid plus base, and this gives you salt and water. Now, this reaction's name is called neutralization. Now, how do you know if something is a base? Something is a base if it's a metal oxide or a metal hydroxide. Okay, so it's either a metal oxide or metal hydroxide if it is a base. So, for example, sulfuric acid plus copper 2 oxide. If it's sulfuric acid plus copper 2 oxide, you recognize the word oxide. Copper is a metal, so copper 2 oxide is a base because metal oxide is a base. So what will this form? Again, it forms salt and water. But what is the salt's name? The salt's name starts with the metal, so it's copper 2. All right, copper is the metallic element, so the salt's name must start with copper. The second part of the salt's name comes from the acid. The acid in this question is sulfuric acid, so it's sulfate. Sulfuric acid becomes sulfate plus water. Next is to write the formula. Sulfuric acid, you memorize H2SO4. Now, copper 2 oxide is the one that you're going to be careful again. It's ionic compound, right? Copper is a metal, oxygen is a non-metal. Copper 2, the 2 means 2 plus charge. The charge is 2 plus. Oxide is oxygen. Oxygen ion, right? Oxygen forms the ion by gaining 2 valence electron. So it's 2 minus. So 2 plus, 2 minus. The formula is just CuO. You just need 1 copper to balance 1 oxide ion's charge because the 2 plus and the 2 minus cancel each other out. Then we come to copper 2 sulfate. Again, got to be careful. Copper 2 is Cu2 plus. Sulfate have to memorize. SO4, 2 minus. So again, 2 plus, 2 minus, CuSO4 plus H2O. Okay, water is H2O. So this is the balanced equation. If you were to count the number of copper, there's one copper, one copper. Metal is done, we move on to non-metal. Sulfate, we can treat it as one unit, SO4. SO4, one of each. So sulfate also okay. Then you realize H2, H2, O, O. So everything is balanced. So you count in this order. You count from the metal. Then you go and consider the non-metals like chlorine, nitrate, sulfate. Okay? Last priority, then you count the H and the O. Now, so this is acid plus base. You know it's a base because it's copper 2 oxide. It's a metal oxide. Next, we go on to a metal hydroxide. So you can see this is hydroxide, sodium hydroxide. Sodium hydroxide is also a base because metal hydroxides are bases. Hydroxide, also a base. So this is also the same reaction. It's exactly the same, just that now the metal is different, right? It's still acid plus base. It's still neutralization. Sulfuric acid plus sodium hydroxide will produce salt and water. But what is the salt? Again, the salt's name starts with the metal. The metallic element in this second case is sodium. Sulfuric acid forms sulfate. So the salt form is sodium sulfate plus water. Okay? Then again, you got to be careful. Sulfuric acid is H2SO4. Sodium hydroxide. Sodium. Group number 1. Group 1, lose 1 valence electron. The ion has a 1 plus charge. Hydroxide is OH minus. So it's NaOH. Because the plus and the minus balance each other out in charge already. Okay, so sodium hydroxide is NaOH. Then we go to sodium sulfate. Also must be careful, right? You know it's an ionic compound, you better write the charges out. Sodium is Na plus. Sulfate, SO4 2 minus. So is the formula NaSO4? This is obviously going to be marked super duper wrong. It's not NaSO4. You cannot assume it's one of each. It's quite obvious, right? Sulfate has a double charge. So you need twice the amount of sodium. 2 sodium, 1 sulfate, Na2SO4 plus H2O. You must write Na2SO4 correctly to get 1 mark. So don't rush. Count the charge, write the charges properly. The next step is to count the elements to balance out. 1 sodium, 2 sodium. So need to put a 2 in front of the NaOH. Now this is where the trick comes in. If whenever you have 2 OH, you will have 2 H2O. So this is a trick, a shortcut. 2 OH on the left means 2 H2O on the right. Okay, so if it helps you balance it faster, you may want to use this shortcut. And this is balanced already. The moment you know that you need 2 NaOH, and because of that, you have 2 OH minus on the left, therefore you have 2 H2O on the right. So this is a shortcut that could help you remember better. Okay, and this brings us to the end of the 3 reactions of acids and how we write equations. Now, if there's one thing I want you to remember is you cannot rush. You need to first start out by learning the charges on the ions, the polyatomic ions like sulfate, nitrate, carbonate. Following that, once it comes to writing equations, you must learn the types of reactions. What is the product? Like today, we named the salt so slowly, right? The salt's name starts with a metal element. Then the second part of the salt's name comes from the acid. You need to write the charges on the ions out when you write the equation. This is to ensure that you get the correct formula. Never ever assume it's one of each ion. Do not assume until you write out the charges and prove to yourself that, hey, it is just one of each ion. Okay, so with that, thank you so much. I shall stop the recording here.